Okay, so very good afternoon to all. Let us start. Second chapter, pressure vessels. So the contents of pressure vessel that we will be discussing. So it includes the thin cylinder types and stresses, design of thin cylinders, numerical. Then thick cylinder types of stresses, failure criteria, then Lami's equation, Clavarino's equation, and Bernoulli's equation, and numerical will be there. No derivations. So it is mentioned here, no derivations for this thick cylinder. Then introduction to compound cylinder, at of retake, unfired pressure vessel. Code is there, IS code that we will be using for this unfired pressure vessel that we will be discussing. And types of end closure. So there are different types of end closure that we will discuss, their geometries and their we can say the specifications or some special requirements of it. And then again, no numerical based on this. Effect of opening and nozzle in shell and covers, numerical treatment will be there based on this. And very important last part is the introduction to ASME, American Society for Mechanical Engineering codes used for design of pressure vessels. So this is very important in industry when a pressure vessel is designed. So based on the application, different codes are used. For example, if in industry is designing, fabricating a boiler, then the IBR, Indian Boiler Regulation Act, that code are used for it. Then any pressure vessel, you can go, anyone can go for ASME section 3 or sorry, section 8 division 1 for this ASME. Then as per as some nuclear component design is there, then section 3 is there, so section NB. So there are different sections, section 1, 2, 3, 4, 5, 6, 7, 8, 9 like this. So section 9, for example, section 9 deals with the welding related aspects. So what are the different considerations in welding, the welder qualification, the welding test and all things related to welding. So these are the things, and in industry, all these ASME codes are referred. So for this ASME course, introduction treatment, this is the newly introduced in syllabus, and we will be taking at the last. So let us start introduction to pressure vessels. Okay, so pressure vessel. So now introduction to this, we have discussed something in our lecture number 1 also. So here you can see. So this is the pressure vessel zone, horizontal type pressure vessel, and another it is the somewhat sphere. So there is one type is there in this. So Horton sphere is there. So this is one of the type. This is spherical pressure vessel, and this is the pressure vessel, horizontal pressure vessel we can say. And again, there are different accessories are shown in this. So this is the there are two manholes, or here it is mentioned as manway. Okay, manholes, then handhole or handway. From this, if at the time of maintenance or wherever required, a person can enter through this. So this is one manhole. Again, here at the top also a manhole is there. So these are the manholes, and this is the pressure nozzle is shown here. So this is a pressure nozzle. Again, see here, this is also a pressure nozzle. Here are the lifting lugs. So lifting lug means it is something. I will show you a drawing. So like this lug is there, and between hole is there. So we can attach a hook in this particular hole, and this bottom side it is welded to the pressure vessel. So this is lug for lifting, LUG lug. So here are two lifting lugs also shown. Here is one lifting lug. Here is another lifting lug. Again, here some cage ladder is also. So these are the means additional things develop on the pressure vessel for a human to enter in this particular vessel. Then this is the horizontal type. So I can say this is the horizontal pressure vessel, and welded supports are there. So this type of support is there. This support is called as, here it is mentioned, saddle type support. So this support is called as saddle type support. Again, we will discuss the detail part. So this is the horizontal type pressure vessel, just for example, and this is the Horton sphere type pressure vessel. So let us start with introduction. What we can call it as a pressure vessel. So vessels, tanks, and pipelines. that carry, store, or receive fluids are called as pressure vessels. So very important word is here, that carry, store, or receive. So there are different aspects in this. If you go in detail, then there are separate categories there. You can call it as storage vessels. You can call it as pressure vessels. So that carry means continuous flow is there. They are receiving or they are storing whatever the types of fluids are there. It is called as the pressure vessel. A pressure vessel is defined as a container with a pressure differential between inside and outside. With a pressure difference between inside and outside, the inside pressure is usually higher than the outside. What is mentioned usually, expect from some isolated situation. So vacuum is some different part. So generally, usually the inside pressure is higher than the outside pressure. You can take here at means very simple example, industrial example we can take as a boiler. But before going for boiler also, very simple example you can take here is our home. In home we are using, that is pressure cooker. So you see whatever the process, whatever we want to cook, that is different matter. But when it is heated, then whatever inside some pressure is develop and steam is escape like this. And see, if you see, it will take some time to release all the steam, and then only we can open the lid of that particular cooker. So it is one of the type, you can say it as a pressure vessel. Then second, you can see in the many sugar industries, boiler. So boiler also you can means it is considered as a pressure vessel. So there are different pressure vessels. Examples that we can take. In simple, we can say pressure vessel is a container uh, with a pressure difference between inside and outside. And generally, the inside pressure is somewhat higher than outside, except for some of the few cases as exceptions, like vacuum may be inside. Okay. The fluids inside the vessel may undergo a change in state, as in the case of steam boilers, or may combine with the other reagents, and in case of chemical reactors. So there are, we can say, different highlighting points. So first point is, the fluid inside the vessel may undergo change in state, as case of in steam boiler. So steam boiler is there. So there may be water, there may be steam, there may be supersaturated steam. So these are the different cases, vapor. So the fluid inside the vessel changing the state. So boiling water, vapors, steam, supersaturated steam. So the moisture content is also changing. So it is changing the state, or may combine with other reagents in case of chemical reactor. If it is chemical reactor, then there are chances that it will get combined with the other reagents within the chemical reactor. Next, pressure vessel often have a combination of high pressure together with a high temperature. Very important. So not only high pressure, we can say for some of the cases or many of the cases, high pressure and high temperature combination. So again, whatever example is mentioned, so you can say here the example is once again boilers, for example. Okay, so in some cases, flammable fluids with highly radioactive material. Because of such hazards, it is imperative that design of such, so that design should be such a way that no leakage will occur. So here, uh, high temperature and high pressure condition may be there. So if something happens, then it will cause human loss, financial loss, and means completely it is disaster like thing. Therefore, if just imagine, or you may know the incidences where the blast of boilers happen. So it is very important. This should not happen due to design failure. So the designer should take care so that no failure will occur, because it is high temperature and high pressure inside it. So some of the cases radioactive material is there. Some of the cases some hazardous gases may be there. Maybe liquid nitrogen may be there. Maybe LPG is not considered as the we can say the hazardous gas, or some like gases which are very hazardous to human being. So if such a case is there, and if leakage happens, definitely more and more loss of human life and financial loss may also there. Therefore, designer should take care in such cases. Okay. In addition, these vessels have to be designed carefully to cope up with the operating temperature and pressure. Very important. Operating temperature and pressure. So what is inside it? It is different. So inside it may be steam, inside it may be water. It is different. Under what condition it is operating temperature and pressure? So a boiler is operating, assume that at 450 degree, 500 degree, or with some pressure. So it is also very important. Or a pressure vessel in submarine, a pressure vessel in nuclear submarine, a pressure vessel in fertilizer industry, a pressure vessel in chemical industry, a pressure vessel in sugar industry. Each of these cases are having the different applications, and the pressure vessel should be designed so that it will cope up with the operating temperature and pressure. Okay, then next is the rupture of a pressure vessel has a potential to cause extensive physical injury and property damage. So that I said, a loss to human life and loss to property means financial losses are there. So plant safety and integrity are the fundamental concern in pressure vessel design. So if anything happen, any accidents related to this pressure vessel failure happens, then there is a physical injury, means human loss, human life loss, and financial losses may be there. So this care should be taken by the designer while the designing of pressure vessel. So these are the typical components of a sample pressure vessel is shown. So we will concentrate main. So very first is the inlet nozzle. So it is shown here. This is again vertical type. So it may be, we have discussed one horizontal case. Now this is vertical case where you can say the inlet nozzle will be there. Then from here outlet, the outlet will be taken here. The inlet of this fluid will be there. Then this is the head. These are the shells. So if you consider this typical geometry, so you can see, I will show you a horizontal case, for example. This is one of the shell. This is second shell. And whenever closure is there, I will call it as a head. So on the both side, hemispherical, toruspherical, we will discuss the types. So this you will call it as a shell made from the plates, and this you will call it as a head. So this is the shell, I can say. This is also shell, and this is the head. Okay. Then some catalyst bed supporting grid is there. Then lower catalyst bed is there. Then this is outlet collector, and this is the one vertical is there. So here is the mention. It is skirt support. In the horizontal case, we have seen there the support used as saddle support was there. Here as a vertical stand is there. So skirt type support. So in any of these, the main components you will observe the inlet nozzle, outlet nozzle, then it is made up of different shells, and head will be there at the top, bottom, or if it is horizontal, I can say on the both sides. Then how it is made, somewhat additional information that we will be discussing here. So here some plates are there. So a one plate is taken, and by rolling the circumference, the required dimension is achieved, and this shell is made. Then here the welding is there at one side. So I will show here. This is the welding. This is the welding for this shell. Again, this is the welding for another shell. So like these different shells are made, and these welds are called as longitudinal welding. It is also called as long seam, longitudinal seam welding. Then these two, for example, cylinder 1 and cylinder 2, they are joined with this weld. They are joined with this weld. So I will call it as circumferential seam welding. So these two shells are joined here. You can see I am highlighting with black. So this is the seam welding. And again, and end closures are joined. These are the heads, or I will call it as end closures. So they are welded here at one side, at the another side of, and now this is gets complete. And then as per the requirement, the manhole and the handhole and the nozzles and the accessories all are provided. So this is the generalized construction and typical components of this pressure vessel. Let us proceed further. The applications of pressure vessels. So pressure vessels are having applications in different areas. So industrial compressed air receiver. So one of the application is air receivers. Then domestic hot water storage tank. So here first application. Then second domestic hot water storage tank. So it is also a pressure vessel. The diving cylinder, scuba diving that we have. Means many of these scuba divers are using this. So what is the cylinder, and inside the oxygen is filled, and the person can be inside the water as far as the scuba diving is concerned, maybe for 1 hour. So this is one of the type of pressure vessel only, so that he can breathe. So this is the pressure vessel. Then recompression chambers are there. Your simple example, you can take compressed air receiver, or this you can see in any workshop, in a college workshop also there are compressors. If you say at any shop, or any we can say auto garage, there are compressors. The compressed air is used for filling the air into the tires. So what we why I am giving these examples? These examples we have we are observing from many days, or we can say from childhood, but we have not seen toward them as a perspective that this is also a pressure vessel. Therefore, I want to create the insight or awareness amongst you that it is also a pressure vessel. So, compression chambers, then distillation tower is there. Then this autoclave in medical industry to sterilize. Autoclave, it is somewhat like a chamber in which in medical industry or in pharmaceutical industry, or in any of the case where the reactions are required to be carried out at elevated temperature, or in controlled atmosphere, or some at high pressure, whatever may be the case. So autoclaves are examples of this. Then oil refineries and petrochemical plants. So it requires pressure vessel. Then typical example I will give you this sugar industry also, you can see the applications of pressure vessels. Fertilizer industry is their application of pressure vessels. Then nuclear reactor vessels, very important. It is having application in nuclear reactor vessels also. Pneumatic and hydraulic reservoirs. So this is also one of the application. And storage vessels for liquefied gases such as ammonia, chlorine, propane, butane, and LPG. See here now, with all gases. So ammonia cylinders. So all these are pressure vessels. What we are observing that. So ammonia cylinders, then chlorine, propane, butane, and LPG cylinder also, it is comes under the storage vessel. But again, it is pressure because the inside pressure is somewhat higher, or as per the desired requirement, as compared to outside pressure. So these all comes under the pressure vessel. So the pressure vessels having a wide variety or wide range of applications in different areas. So let us discuss something about the generalized or general materials for pressure vessels. And again, based on the types also that we will discuss. The materials that are used in pressure vessel construction are steels, non-ferrous materials such as aluminum and copper, and their alloys. Copper means don't consider as pure copper. Alloys are also there. Then metals such as titanium and zirconium. Titanium, based on this, we can say a corrosive environment and high temperature resistance. Then non-metallic materials such as plastic, composite, and concrete. So non-metallic materials, depending upon application, they are used. And metallic and non-metallic protective coatings also there. Means one of the material may be of steel, but or maybe of mild steel, but it should not corrode. So a cladding, I will call it as cladding, CLADDING, cladding. A layer is given of stainless steel so that it will not corrode. So this is also protective coating. So various materials having some typical characteristics. So let us have a look towards this. So it includes this carbon steel. Strength and moderate corrosion resistance is there. Then low alloy steel having strength at higher temperature. Then stainless steels, corrosion resistance is there. Then nickel alloys, again corrosion resistance. Then aluminum, light and low temperature toughness is there. Then titanium, seawater, chemical resistance is more. Refractories, very high temperatures are there. then it is used, and non-metals, they are best for corrosion and chemical related. So these are the some guidelines given. Now corrosion resistance, one can go for stainless steel, one can go for nickel alloys or chromium or titanium. So it is not based on the only corrosion. So in what atmosphere, at what location, what is the desired requirement of temperature, pace, and again cost is also very important. So by considering all these factors, the material is selected. So these are general guidelines that what the any material is having properties as per the selection of material for any pressure vessel is concerned. So next point now, factors affecting selection of material. Now we have discussed what are the different materials, how to select. That's why I have said now just before that only corrosion resistance is not deciding the material. So factors affecting the selection of materials are process fluids. So what is the fluid that is being processed? Operating temperature, operating pressure, fluid velocity. Now we will take one example based on this. Process fluids. If I want to process any gas, lethal, very toxic, and leakage of this gas can cause the many deaths of human life. Very dangerous. So that process is there. Or you are going for water, or you are going for any oil, or you are going for petroleum, diesel like this. So what is the processing fluid? What is the operating temperature and operating pressure? For example, you take any boiler, then the operating temperature for the boiler, and again it is going to converting to steam. So it may be 400, 500. Then operating pressure, it may be 10 psi like this. Then fluid velocity, again it is having higher velocities. These are the some examples. Contamination of product. So are there any chances as far as the contamination is concerned? Whether it is explored to any toxic environment in, or I can say chemical industry. If a pressure vessel I will be using in general requirement, then somewhat corrosion requirement in fertilizer industry, in sugar industry, then in pharmaceutical industry, more chemicals reactions may be there. Then any chemical reactor plant, any atomic energy reactor, and in submarine. So the same tank may have different material selection based on the different conditions. Very simple. So this is related to contamination. Therefore, I have given you these 5, 6 examples. So you will be now idea is clear that what is the effect of this environment on the selection of this material for pressure vessel. Then required life of the equipment may choose to incur shorter life and replace more often. So there are two options. For example, you take any product related to nuclear submarine, any product related to atomic energy sector, then simply it can be said that no means replace more and more often time it is not possible for such cases. So 30 years, 40 years life may be desired for such cases. Very simple. Okay, so because uh, if the pressure vessel is used in nuclear submarine, then there are very less chances that it will be replaced. So whatever the life of that submarine is desired accordingly, this life of pressure vessel is considered. Okay, so any other components may choose to incur shorter life. So shorter life can be taken and the pressure vessel can be changed after some intervals of time. And very important, the cost of material of construction. So again, here the alloy steel, stainless steel, again titanium like alloys, chromium nickel alloys, very costlier. So the cost of material for construction, base material is there, means cost of titanium plus fabrication a vessel or fabricating a pressure vessel from titanium, fabricating a pressure vessel from stainless steel, chromium, nickel alloy. Again, it is costlier because the material is costlier. Therefore, all the fabrication cost also go, and ultimate cost of the product or pressure vessel will be higher. So these are the factors which will affect the selection of material. They are, once again I will repeat, the process fluids which is inside the pressure vessel, then the operating temperature, the operating pressure, the velocity of fluid, the contamination of product and required life, whether it is a long life or it is permitted that the pressure vessel can be replaced after some intervals of time or some interval of time, and then cost of the materials of construction. Okay, let us proceed further. The classification of pressure vessels. The pressure vessels are classified in different ways. So we will discuss one by one. So based on the wall thickness, thin wall and thick wall vessels or pressure vessels. We will be discussing the definition also. It is based on this thickness is in terms of diameter. So 1 by 15th of diameter, the ratio is given, and it will decide less than 1 by 15 or greater than 1 by 15. It will decide the pressure vessel is thick or pressure vessel is thin. Based on the geometric shapes, the pressure vessel may be cylindrical. We have discussed now examples. Then spherical, Horton sphere, that also I have shown you, rectangular vessel or combined vessel. Then based on the installation methods, these both examples we have seen in slide. Vertical vessels, a vessel is erected vertically, vertical vessel or horizontal vessels are also there. Then further we will proceed more detailed classification of these pressure vessels. So based on the operating temperature. So low temperature vessels, normal temperature vessels, medium temperature vessels, and high temperature vessels. So based on this, low temperature vessels, less than or equal to -20. Normal temperature between -20 to +150. -20 to +150. Medium temperature, it is from 150 degree Celsius to 450 degree Celsius. And high temperature vessels, it is the range more than or equal to 450. So boilers fall under this high temperature vessel category. If it is operating approximately assume at 510 degrees Celsius, then we can call it as a high temperature vessel. Then based on the design pressure. So we will discuss the terms. What is the design pressure? So design pressure, low pressure vessels, medium pressure, high pressure, and ultra high pressure. Low pressure vessels 0.1 megapascal to 1.6 megapascal. Medium pressure vessels 1.6 megapascal to 10 megapascal. High pressure vessels 10 megapascals to 100 megapascals. Ultra high pressure vessels more than 100 megapascals. Based on the technological process. Reaction vessel, heat exchanger vessel, separation vessel, storage container vessel. Based on the technological process means what the pressure vessel is intended for, what it is made for. If it is made for only storage purpose, the liquid, the water, the gas, and the other things, just only storing in it, then it is storage container or storage vessel. Then if any chemical reaction or any nuclear reaction is happening inside the vessel, then it comes under the reaction vessel. Then heat exchanger vessel. So it is separate type heat exchanger. The heat is exchanged. It is also required in many applications. So it is heat exchanger or separation vessel. It is used for separating one item from another. So we can call it as a separation vessel. So these are the different things. Then next, I will be proceed for next. These are just now we have seen the different examples. So here we can say the horizontal and vertical example. We can see here clearly. So what is this? It is shown. I can give the name as per as the orientation or the position is concerned as horizontal pressure vessel, and here I can say it as the vertical pressure vessel. So horizontal pressure vessel and vertical pressure vessel. A saddle type support is there and all the things. So the location it indicates horizontal and vertical type. Again, see the different configurations are shown. So all these examples are vertical only. The this is also the case of, you can say, the vertical pressure vessels. Okay, these are the lugs. So this is the bracket used as a lug, which will be helpful for lifting this. And this is the main sail. Then this is the downside and upside of the dished, or you can say the descend. This part and this part is the dished end. Okay, so these are the different orientations as per as this whatever we have discussed in this vertical and installation method, vertical and horizontal. So these are the vertical and horizontal cases. Now let us see the difference between the thin shell and thick shell pressure vessel. So very important concept, thin and thick. So the thickness, if the thickness of the shell or pressure vessel is less than 1 by 15th of diameter, is less than 1 by 15th of diameter, then it is called as thin shell. And if the thickness is greater than, if the thickness is greater than 1 by 15th of diameter, then I will call it as thick shell. Okay, 1 by 15. So let us assume, I will take here one example. The diameter as 90 millimeters. The diameter as 90 millimeters. So 1 by 15. So 1 by 15 into 90, 6. So if the thickness is less than 6, I will say thickness as 5 millimeters. So it is less than 6. 90 divided by 15. So I will call this as thin shell. And the same example I will take. The diameter is, for example, 90 millimeters. And the thickness you assume 10 millimeters. So 1 by 15. 90 divided 1 by 15 into 9, 6. So this 10 is greater than 6. So I will call it as thick shell or thick cylinder. So this is the example. Then the internal fluid pressure in this case. So internal fluid pressure is less than 1/6 of the allowable stress. Internal fluid pressure is greater than 1/6 of the allowable stress. An application, thin shell used in boilers, then tanks and pipes, and used is in high pressure cylinder. So as the thickness is more, high pressure cylinder is the application. So tanks, gun barrels, these are the different examples of this thick cylinder. Okay, so this is the difference. So you keep very important in mind that here I will repeat the thickness. The thickness is less than 1 by 15th of diameter, and here the thickness is greater than 1 by 15th of this diameter. Very, very important. Okay, so this is about the difference between the thin and thick pressure vessel.